right, so we are going to look at the Unit 2 review here and just go over the questions. So for ones where you did not know how I got the answer that I got or forget what I went over when we went over this in class, you can kind of find the problem you need, hopefully, and listen to the explanation. So if it'll let you fast forward, you can do that if the technology is cooperating. So 1, 2, and 3 are factoring, and when we are factoring, we have factoring order of operations. So the first thing we always do is we look for and take out a GCF. Second thing we look for are our special products, which are difference of squares and PSTs. Step 3 is if we don't have any of those, we're going to do some chart factoring. And there were also 2 types of chart factoring. There were factors that add and split the middle. So let's go through each of these for our problems. So number 1, first thing I do is look for a GCF. There is nothing that all 3 of those terms have in common. So I move on to number 2, special products. I know this isn't a difference of squares because difference of squares only have 2 terms. They're binomials. So I look at PST. This is not a PST because PSTs have perfect square roots. 15 does not have a perfect square root. So I know this has to be chart factoring, so I'm going to set up my little chart. To know whether it's factors that add or split the middle, you're just looking at the squared term. If there's no number in front, then that means it's a factors that add. If there is a number in front, that means it's a split the middle. So since it's factors that add, I'm simply looking for factors that multiply to give me 15 and add to give me 8. So multiply to 15, add to 8. So go through your factors of 15. 1 and 15, 3 and 5. Which of those add to 8? These ones right here. So that means I fill in a plus 3 and a plus 5 into my parentheses. And that is it for that one. Number 2, again, always go through the order of operations. First I look for GCF. All 3 of these terms have a common factor of 2, so I take that out first. So that leaves me with x squared minus 2x minus 15. Then I need to look at what's left after I've taken the 2 out, see if it factors further. Not a difference of squares because it's not a binomial. Not a PST because 15 doesn't have a perfect square root. So again, I'm going with chart factoring. This one again is factors that add. This time I'm looking for what multiplies to negative 15 and adds to negative 2. So to multiply to negative 15, it could be negative 1, 15, positive 1, negative 15, positive 3, negative 5, or negative 3, positive 5. So the ones that add to negative 2 are positive 3, negative 5. So don't forget that 2 out in front, but positive 3, negative 5 is what we fill into our parentheses. And there is our final factored answer. On number 3, I look for a GCF. There's nothing in common between 49 and 64. So I go to special products. Could this be a difference of squares? Well, this is the first one that has 2 terms, so it has a possibility. In order to be a difference of squares, both terms have to have a perfect square root and they have to be separated by subtraction. So square root of 49x squared is 7, so that works. Square root of 64 is 8, so that works. And it is subtraction, which means this is a difference of squares. And when you factor a difference of squares, one of the parentheses gets a plus, the other gets a minus, and you just fill in this first square root to the fronts and the last square root to the back. And so we've got 7x plus 8 times 7x minus 8. Number 4 and 5, so this is like what we did on the Let's Get Radical. We need to simplify those radical expressions. And we can do that. On number 4, we have to break down the 108, so you can either use a factor tree or you can use biggest perfect square. So if I'm looking at that and going to break down my 108, I need to come up with at least one set of factors that will give me 108. And if you don't pick the same ones as me, that's okay. Let's say that we did 4 and 27. So 4 is 2 times 2, 27 is 3 times 9, 9 is 3 times 3. So when we do this, the pairs get to come on the outside. So I have a pair of 2s and a pair of 3s. So a 2 and a 3 get to come on the outside. This 1 3 that doesn't have a pair stays on the inside. And then final step is to multiply these two together that are on the outside. So 6 radical 3 is our answer. On number 5, many different ways to do this. I started by giving them each their own symbol. And then I multiplied the fraction. So radical 3 times radical 1 is radical 3. Radical 2 times radical 7 is radical 14. Then 14 doesn't break down because it doesn't have any perfect square factors, neither does 3, so there's no simplifying there. But what I do have to do is get rid of that radical in the denominator by rationalizing. So multiply the top and bottom by your radical 14. So that gives me radical 42 on the top. On the bottom, that gives me a plain 14. The radical 42 does not break down because remember that 42 is 6 times 7. 6 is 2 times 3. There's nothing to pair with. So it's not prime, but it doesn't break down for the radical. All right, number 6. Please do not try to multiply here. This is subtraction and addition. So the first thing I need to do is distribute this negative. So make that a minus 3 plus 5i. And then from that point on, it's just combining like terms. So I've got 5 minus 3, which is 2. Then I've got negative 2i plus 5i plus 4i. So negative 2 plus 5 is 3. Plus 4 is 7, so plus 7i, so 2 plus 7i. Number 7, this is multiplication, and since it's a binomial times a binomial, we have to FOIL it. So F is for first terms, 2 times 4 is 8. O is for outside terms, 2 times negative 5i is negative 10i. Inside terms, 3i times 4 is 12i. And last terms, 3i times negative 5i is negative 15i squared. I've got a lot of people still forgetting the squared, and that's really important because we know that I squared is negative 1. So this negative 15i squared is really just a plus 15. So now it's a like term with the 8. 8 plus 15 gives me 23. Then negative 10i plus 12i gives me 2i. So 23 plus 2i is my answer. On number 8, the reason why that is not in simplest form is because I can't leave an I in the denominator. So much like up here where I had to multiply the top and bottom times the radical, here I have to multiply by the complex conjugate. So all I do is take whatever the denominator was and change the sign. So 4 minus I is the complex conjugate, and then multiply that on top and bottom. So on top, when I multiply these, this is a binomial times a binomial again. You have to FOIL it. So firsts, 2 times 4 is 8. Outsides, 2 times negative I is negative 2i. Insides, 3i times 4 is 12i. And lasts, 3i times negative I is negative 3i squared. On the bottom, you also need to FOIL, but this is a sum and difference pattern. The insides are 4i, the outsides are negative 4i, so those are going to drop out. So I just have to do the firsts and lasts. First is 4 times 4, so 16. Lasts, I times negative I is negative I squared. So now combine your like terms and take these I squareds and turn them into their plain number equivalents. So minus I squared is really like a plus 1. Minus 3I squared is really like a plus 3. So 8 plus 3 is 11. Negative 2I plus 12I is 10I. And 16 plus 1 is 17. And there are no common factors between those three terms, so that means that I am finished. 11 plus 10I over 17 is my answer. 9 and 10, find the discriminant, tell how many and the type of solution. So first part of the directions is find the discriminant. Remember that the discriminant is b squared minus 4ac. So I look here, b squared would be 10 squared minus 4 times a, which is 1, the number in front here, times c, which is 25. So 10 squared is 100. 4 times 1 times 25 is also 100, so I end up with 100 minus 100. So the discriminant is 0. Now tell how many and the type of solutions. This is from your 5-6 notes. You just have to have this memorized. You have to know if the discriminant is 0, that means that there is one real solution. If the discriminant is negative, that means there's going to be 2 imaginary solutions. If it's positive, there's going to be 2 real solutions. So you have to know those. Those are in your 5-6 notes. So next, same thing, different problem. So b squared minus 4 times a times c. So 2 squared is 4 minus, so 4 times negative 1 is negative 4 times negative 4 is positive 16. So that gives me 4 minus 16, which is negative 12. So when the discriminant is negative, that means that there are 2 imaginary solutions. All right, moving right along, number 11 and 12, solve by factoring. So we're still going to be using this order of operations up here. If I'm solving by factoring, first thing I'm going to do is factor it. So I look here, the GCF. It can't be a difference of squares because it's 3 terms. It can't be a PST because 2 and 30 don't have perfect square roots. So that means it's going to be chart factoring. It can't be factors that add because there's a number in front of the squared term, so it has to be split the middle. So on split the middles, I'm looking for what multiplies to 2 times negative 30. So what multiplies to negative 60 and adds to the middle, which is 7. So you've got lots of factors that would multiply to negative 60. So let's say that you try 10 and negative 6. Those multiply to negative 60, but when you add them, it gives you 4. So we need them a little bit further apart than that. So let's try 12 and negative 5. Those multiply to negative 60. Oh, and they add to 7. So these are the winners. Now, do not fill these into the parentheses. On split the middle, you use these answers to split this middle term. So in the next step, I split that 7x into positive 12x and negative 5x from here. Everything else about it stays the same. So now, once I do that, then I can factor by grouping. So I take these 2 together and these 2 together. I look for the GCF of my first group. So that's 2x. If I factor out 2x here, I would have x plus 6. Whatever the first parenthesis is, the second one has to be the same. They have to be identical. So then I just work backward. What do I multiply x by to get negative 5x? So hopefully you said negative 5. And so now I'm ready for my final factored answer, which is 2x minus 5, because that's what's in the fronts, times the parenthesis that they share, which is x plus 6. Do not forget, please, I beg you, on the test, it's solve by factoring. After you factor it, you have to still solve. So set each of those equal to 0. and get x by itself. So here, add the 5 and divide by 2. So that gives you x equals 5 halves. Here I just have to subtract the 6, so negative 6. Number 12, solve by factoring. Again, I'm going through that same order of operations. So there is no GCF there. I look at special products. This has 2 terms, so could it possibly be a difference of squares? Does x squared have a perfect square root? Yes, it's x. Does 25 have a perfect square root? Yes, it's 5. They're separated by subtraction, so that means it is a difference of squares. One parenthesis gets the plus, the other gets the minus. Square root of the front goes in the front. Square root of the back goes in the back. And then again, don't forget that this says solve, so that means we have to set each of them equal to 0. So x equals negative 5 and x equals positive 5. 13 and 14, solve by finding square roots. The key here, guys, remember, is you cannot take square roots until the squared term is alone. So on number 13, first I have to add the 8. So that gives me 2/3 x squared equals 24. Then, still x squared is not alone. I have to get rid of this 2/3 by multiplying by the reciprocal. So multiply both sides by 3/2. So those cancel. X squared equals 24 times 3/2 is 36. Now my square term is alone. So now I can solve by taking square root. So square root, both sides. X equals, don't forget your plus or minus. The square root of 36 is 6. Same idea on 14, except here the squared term is this instead of just a plain old x squared. But that in my little pink box is what I have to get alone. So first I subtract the 4. So 3 times x minus 2 squared equals 48. Then divide by the 3. So x minus 2 squared equals 16. Now my squared term is alone. So now I can take the square root on both sides. So x minus 2 equals, don't forget the plus or minus. As soon as you take square roots, you need plus or minus. So finally, I'm going to add 2. So I've got x equals 2 plus or minus 4. Now, there's more work to be done here because in this case, these are like terms. 2 plus 4 is 6. 2 minus 4 is negative 2. And so those are our final answers. 15, solve by completing the square. So this is section 5.5. In order to complete the square, you have to have it in the form x squared plus bx equals c. So I have to move this 3 over by adding it. So x squared plus 8x equals 3. So now, next step in completing the square is to factor out the coefficient of the squared term. Well, there is no coefficient of the squared term there. It's just 1, so I don't have anything to factor out. After that, I add my blanks, 1 on each side of the equal sign. I fill in the blanks with b divided by 2 squared. So in this case, my b is 8. 8 divided by 2 squared is 16. To fill in the blank on the right side, you multiply times whatever was out in front, which again, in this case, there was nothing out in front, so it's a 1. 1 times 16 is 16. After that, I factor the left side as a PST. So square root of x squared is x, square root of 16 is 4, sign of the middle term is a plus, and then it gets a squared. Over on the right, add those like terms, gives me 19. So now I can take the square root on both sides because the squared term is all alone. So square root gives me x plus 4 equals plus or minus radical 19. Radical 19 doesn't come out evenly and it doesn't simplify. So the only thing left to do is to subtract the 4 here. So that gives me x equals negative 4 plus or minus radical 19. Same idea on 16. Very first, I need to get it in the correct form. So add the 14 first so that the x squared and the x term are on the left. The c is on the right. After you've got it in the right form, factor out the coefficient of the squared term. So factor out the 2 on the left side. So that's going to give me x squared minus 2x now. Once you have that done, now you can add your blanks. So this one goes inside the parenthesis, the other one on the other side of the equals. So now fill in the blank. So here's my b. b is -2, so -2 over 2 squared. So -1 squared is 1. And then multiply 2 times the 1 to give you 2 over here. So now on the left, I need to factor that as a PST. Square root of x squared is x. Square root of 1 is 1. Sign of the middle term was a minus. Over on the right, 14 plus 2 is 16. Do not take the square root yet. You don't have the squared term alone because you've got this 2. Divide by 2 first. So you've got x minus 1 squared equals 8. Then you can take the square root on both sides. So that's going to give you x minus 1 equals plus or minus radical 8. Radical 8 you need to simplify because it's divisible by 4. So that's going to be 2 radical 2. And so then your last step is to add the 1. So add the 1, x equals 1 plus or minus 2 radical 2. 17 and 18 should be your favorite, solving using the quadratic formula. If you are having trouble with this, it's telling you that you are still struggling with order of operations, with using your PEMDAS. You have to know the quadratic formula. Remember, it will not be given to you. You have to know it. So opposite of b plus or minus square root b squared minus 4 times a times c, the whole thing divided by 2a. So in this case, my a is 1, my b is -9, and my c is 5. So opposite of b would be +9 plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. So simplifying using PEMDAS, on the inside of that square root, -9 squared is 81 because exponents come first. Next comes multiplication. So I have to multiply these 3 things together first before I do the subtraction. 4 times 1 times 5 is 20, so that gives me a -20 here. So then I've got 9 plus or minus the square root of 61 over 2. I would try to simplify next. 61, however, does not break down. There's no radical simplification to do there. And no like terms to reduce, so that is just going to be my answer. On 18, it's not equal to 0 right now. Do not start assigning a, b, and c until it's in the right form. So move these to the left side, so that gives me 5x squared plus x plus 1 equals 0. So that means a is 5, b is 1, and c is 1. So opposite of b plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. So simplify. Those parts are the easy parts. The under the square root, the discriminant part, is the harder part. So 1 squared is 1. Again, you have to do the multiplication. 4 times 5 times 1 is 20. So I've got 1 minus 20, which is -19. I know I have to simplify there because I can't leave a negative under a radical. That brings out an I. So negative 1 plus or minus I radical 19 over 10. Now, there's nothing else I can do with that radical. 19 doesn't have any perfect square factors, no reducing in this case. So that is going to be it. Number 19, this is honors only. So regulars, you do not have to do this one. To solve a quadratic system algebraically, first get them both so it's y equals, so subtract this 2. So y equals 3x squared plus 5x minus 4. And then we're going to solve it by substitution. Since these both have a y, that means I can take y out here and put this in its place. So I'm going to put 3x squared plus 5x minus 4 equals x squared minus 6x minus 16. Now I'm going to solve this quadratic. So I'm going to get it all to one side. So I'm going to move this over. So that it's equal to 0, so I can see what I'm looking at. That gives me 2x squared plus 11x plus 12. So you have a choice here. This is a quadratic. You can solve it however you want, at least any method that will work. I know that that is factorable because I look at 2 times 12 is 24. Factors that multiply to 24 and add to 11 are pretty easy. It's 8 and 3. So I'm just going to factor this by splitting the middle. If you prefer to complete the square or use the quadratic formula, you can certainly do that as well. So I split that middle term into plus 8x and plus 3x. And then I factored by grouping. So the first group has a GCF of 2x with an x plus 4 left. So that means the second group has to have an x plus 4. If I work backward, what do I multiply x by to get 3x? That'd just be a plus 3. So factoring, the fronts are 2x plus 3, and the parenthesis they shared is x plus 4. So if I set each of those equal to 0, if 2x plus 3 equals 0, subtract the 3, divide by 2. So x equals negative 3 halves, and this one would give me x equals negative 4. Number 20. Graph the quadratic equation, then fill in the appropriate information. So this is in standard form, which means we find the vertex by doing opposite of b over 2a. So opposite of b would be positive 8, 2 times negative 2. It's going to give you a, so 8 over negative 4, which is negative 2. So the x-coordinate of the vertex is negative 2. If you want to find the y-coordinate, plug negative 2 in. So that's going to be negative 2 times negative 2 squared minus 8 times negative 2 minus 5. So negative 2 squared is 4. Negative 2 times 4 is negative 8. This gives you plus 16 and minus 5. So negative 8 plus 16 is 8, minus 5 is 3. So the y-coordinate of the vertex is positive 3. So I can go ahead and plot that, negative 2, positive 3. Then you can look at the t-chart in your calculator. So press second graph and scroll so that you're around where x is negative 2. If you look and see the other points, just above it at negative 1, the value is 1. At 0, the value is 5. And just below it, at negative 3, it's 1. And at negative 4, it's also 5. So I can plot those other points on there. And graph my parabola. Fill in the information. The axis of symmetry is always x equals the x-coordinate of the vertex, so x equals negative 2. My domain, my x values go on forever, both to the left and to the right, so that means my domain is all reals. The range, my y values start here at 3 and they get smaller. So That's all reals less than or equal to 3. My y-intercept happens to be in my t-chart, but if it wasn't, you just plug in 0 for x. Obviously, we can see it here. When x is 0, y is 5. So 0, 5 is going to be your y-intercept there. Number 21, people always miss this one because they think that they need to graph and shade. This does not have a y. It's a single variable, which means you sketch the graph. It's a sketch, not a graph. So it looks something like this if you graph it in a standard window. You don't need to see the bottom because all you need are the zeros. So find this, and you'll be good to go. So we find zeros in the second trace menu. So for this 0 over here, left bound would be over here because we're to the left of that 0. So that's left bound. Over here is right bound. Then tell it yes to enter. It should tell you that that 0 is x equals -6. Do the same thing over here, but left of this 0 is down here. This is left, this is right on this side. And so it should tell you that that 0 is at x equals 3. Again, your sketch doesn't have to be perfect. Mine looks like it's 2. That's fine. We're using the calculator to find the zeros. So then I need to look at this symbol. That's a less than. So I am looking for the part of my sketch that is less than 0. So that's this. It's the loop of the parabola. And we said in the 5-7 notes that if the part you're after is the loop, you take the zeros and write a sandwich. So I'm going to sandwich x between my two zeros. Oops, why did I put negative? +3. So x is between -6 and +3. Number 22, graph the system of inequalities. So really, we're just graphing these two different parabolas. So the first one, find the vertex, opposite of b over 2a. So the x-coordinate of the vertex is 2. When I plug that in, 2 squared minus 4 times 2 plus 3. So 4 minus 8 is -1. Or -4. -4 plus 3 is -1. So that's my vertex. Again, you can use your calculator to come up with the other points. I do both my vertexes first, so I move over here next to find my vertex. So opposite of b, opposite of 5 over 2 times a. So that's -5 over -2, which is +5/2. So that's the x-coordinate. Then plug that in to get the y. It's harder to plug in a fraction, but you should be able to do it. So opposite of 5/2 squared plus 5 times 5/2 plus 6 is what we're going to be plugging in. So you can use your calculator to help you if you need it. 5 over 2 squared, you would just square the top and square the bottom. So that's going to be 25 over 4. And then because the negative's in front, that's going to be -25 over 4. 5 times 5 over 2 is 25 over 2, and then plus 6. So we just need to combine those like terms there. So if I've got -25 over 4 plus 25 over 2, that's going to give me +25 over 4. And then when I add the 6, it's going to give me 49 over 4, which is 49 over 4 is 12 1/4, 12 1/4. So that means we're looking at this as your vertex. The reason I do both the vertices first is for situations like this. If I count by ones, I'm not going to be able to fit my second vertex. So that just tells me I need to count by twos. So now I can look in my calculator. You can graph them both at the same time and look at both t-charts at the same time if you want. But you need to get, it says, list the vertices. So we did that. We need to clearly mark at least 2 other points on the parabola. So on this one here, when we're looking at that chart, and of course our vertex again is at 2, almost put a negative there, 2, -1. So if I look around that point there in my graphing calculator, the other points are 1, 0, 0, 3. Over here I've got 3, 0, 4, 3. On my second parabola, when I'm looking in, and again, I know where my vertex is. The vertex, again, is not going to be in the chart because it's fractional. So the rest of my t-chart I can get from the table. And remember, 5/2 is like 2.5. So right below that is 2, 12. And then we've also got 1, 10. And then 0, 6. And then just above the vertex, we've got 3, 12, 4, 10, and 5, 6. So again, it only says you have to clearly mark at least 2 other points. So any of those points in the chart you could choose and that would be fine. So now let's go ahead and graph them. So we'll do the blue one first. So 2.5, 12.25, 2, 4, 6, 8, 10, 12.25, so just a little above. And then again, you can pick any 2 other points in here, 1 on each side. So I'm just going to go with 0, 6 and 5, 6. This parabola should be dashed because it has no equal sign underneath. And now I just need to shade it. So I need to pick a test point that's on the inside of the parabola. So I'm going to pick 0, 0 because it's inside. So I'm going to write down to test 0, 0. Remember, when you're testing a point, you're just plugging it back in here and seeing what it gives you. So plug 0 in. 0 is less than 6 is what I get. That is a true statement. So I am going to shade the inside. On my second parabola, when I graph it, 2, -1 is my vertex, and then for my other points, I'm going to pick the 0, 3 and the 4, 3. This one should be solid since it has the equals underneath. Pick a test point. Now on this one, you can't pick 0, 0 because 0, 0 is outside the parabola. So I'm going to go ahead and pick 2, 2. So test the point 2, 2 and plug that in again to this equation. So 2 is less than or equal to 2 squared minus 4 times 2 plus 3. So when I simplify that right side, 4 minus 8 plus 3 is -1. So 2 is bigger than -1, so this is also true, which means we're going to shade the inside of that one also. And then our final answer is where those 2 shadings overlap. So where you see both the green and the blue is your answer. So I'm going to make that part red to make it stand out. All right, very last one. This is all in your graphing calculator. So in your graphing calculator, graph this equation. Obviously, you're going to be using x for t. And remember that the most important thing on these ones is what your variables stand for. So your x is time. Your y is height. That's important because if it's asking for a height, you know it's asking for a y coordinate. If it's asking for a time, you're looking for an x coordinate. So when you graph it, remember it's a real life problem. You're going to have to adjust the window. So you need to make it go up high enough so that you can see your vertex. It should look something like this. When it asks for the maximum height, that's asking for the y coordinate of the vertex. This is the max. So we want y coordinate of the maximum. So to do that, you do second trace, max. Do left bound, right bound, and it should, hopefully, spit out the answer for you. And make sure we're reading the directions. This one says round to the nearest tenth. So that's going to be 76.6 feet is what you should have gotten for the y coordinate of your maximum. The next one says, what is the time that the boiling water reaches the maximum height? So again, time is x coordinate. So you don't have to do anything else in the calculator. It's the exact same thing you just did, except now we're looking at the x coordinate of the maximum. So if you already deleted what you did in A, then you'll have to repeat it. But otherwise, if it's still there, just look at what the x coordinate of that maximum is. Again, rounded to the nearest tenth, that's going to be 2.2 seconds. Last question, how long is the boiling water in the air? If you're asking how long, this is asking for time. So again, you're looking for an x value. How long it's in the air. If you think about this picture in relationship to the problem, it's the geyser erupting. So here goes the water. Here it comes back down. Here is where it hits the ground. So the time that it's in the air is right here. So all this is really asking me for is to find that second zero, the second x-intercept right here. So do second trace and then choose choice 2 to find the 0 and rounded to the nearest tenth. That should be 4.4. Don't forget your label of seconds. All right, happy studying. Redo them until you can do them by yourself.